Welcome to part 3 of this project to design, prototype and then 3D print an adapter hat for an 18-volt trill battery. In the first part we measured up the battery and made a 3D model of an adapter in Fusion 360, and then we printed it. In part 2 we then corrected almost all of the errors made in part 1 and we added some new ones. In this video we'll hopefully finish adding features to the model. Then we'll look at refining the model so that it not only looks and feels nicer, but is also easier to print. Then we'll send it off to print. Now, some of the more forward-thinking of you may have been wondering just how 3D printed plastic that melts at 200 degrees will hold a 300 degrees Celsius soldering iron for more than just a few seconds. Well, let me put your mind at rest by simply showing you one that I made earlier in true Blue Peter fashion. This is one that is made up of several models that I downloaded from Thingiverse. But what I did with this is that I inserted a short piece of ordinary household 15mm copper tubing to act as a liner. Now, what you can't see, but at the very bottom of this tube, I cut a couple of slots in the copper and pressed in part of it so that it would kick the soldering iron away from resting on the edge of the copper tubing and heating up the plastic directly. Also, I designed in a couple of little vent holes at the base of it, which allows for some convection to carry some of the heat away. This has worked very well so far. It has withstood more than 20 minutes of the soldering iron being on and up to temperature without warming the plastic enough to be worried about. So I'm going to add a similar sort of soldering iron holder to this model. So we need to make a new sketch, but unlike the sketches we've made previously, we have not got a surface to reference it to. There isn't an existing feature on this model that is at the right angle that we want. Now, I can almost hear all of you Fusion 360 experts yelling and screaming about better and more accurate and easier ways to do it. And no doubt there is more than one way to skin this particular mouse, but this just happens to be the way that I know and that I'm comfortable with. If we orient the model to being this way up, and then go to the Construct menu and select Plane at Angle, we can then click on this rear edge. If we turn it sideways, you can see that a plane has been introduced, and we can adjust the angle of this plane to whatever we want. The angle I want is minus 45 degrees. Click OK at that. Now we can create a new sketch and actually use this plane that we created as its basis or origin. Now, very helpfully, Fusion 360 has turned the view upside down. So let's just leave that right like that. And what we want to do is create a couple of concentric circles. The first one is going to be 15mm. This is for our copper tube, and then for the outer wall we're going to make one at 25mm. Now we can use the tangent constraint tool to be able to make this always stay right touching the edge of our model. And we could leave it at that. We could just extrude that. That would be able to be stuck to our model. But let's add a little bit more finesse to this, just by adding a couple of 3-point arcs to our model. We can just really add a lot more strength, and also it will look a lot nicer too. So if we press E for extrude, we can then select various parts of this, and we'll just extrude this way longer than we need. Under operation here, we're going to ask it to join. I will hopefully join that to our existing model. We click OK. That seems to have worked. Let's just have a look at this. Isn't this the most beautiful thing that you have ever seen in your entire life? But you may have noticed we've covered up one of the holes to our mounting for our switch. Well, we can easily solve that. We can go back into our drawing by double clicking it on our timeline, and we can drag this down. Notice our little arc here has gone a bit astray, so we'll just adjust that. If we finish that, let's see if that's made it enough. No, not far enough. So we just do that again. Finish that. Ooh, so close. I think we can make do with that, and we will sort that issue out in just a minute. Now, as beautiful as this model undoubtedly is, we can do a few things just to make it that much better. Again, there are bound to be millions of ways of doing this. Well, dozens. Never mind. The way that I like to clean up things like this is to go up to the Modify panel and use the Split Body command. So we click to select the body to split, and then as a splitting tool we can actually use a surface of the same body. Click OK. You notice now we've got two bodies. We can hide that second one, and we can do the same underneath. Split body, select the body, select the face, and hide. This one. We can try doing the same. Select. For some reason it doesn't like to do that. So what I like to do in this case is just use the extrude command after clicking on this little corner, and we can pull that all the way back. Click OK. Now to fix this little hole here, we have to go back to find our drawing for that, which is sketch 9. We go back down to sketch 9 and we make it visible again. Let's just zoom in. So what we can do is we can extrude this outwards, which will cut. That's solved that issue. Now I know I promised you that we will model up the cable exit, but I just realized that on this model we already have two exits already created. I'm sure we can use one of these just fine to exit the cable to go to the soldering iron. Now when it comes to modifying this model to either make it easier to print or nicer looking, yeah, I know you're all thinking, how can it be possible to improve on this? But stay with me on this. We should be able to make it a little friendlier to handle and also easier to print. Now we deliberately modeled this so that the top, as we're looking at it now, will be the top when it is printed. And it's important to think about just which way your model will be oriented when printing it on your 3D printer. As all know, as most, well well, probably just my 3D printer is really rubbish at printing in thin or even thick air. So often I have to use printed supports for areas that overhang. But it is possible to make some alterations to a design that will reduce, if not eliminate, the amount of unsupported overhangs, thus reducing or eliminating the need to use printed supports. And we often do this by adding fillets and chamfers. So now I'm going to do just that and add some fillets and chamfers around this model. I'm a bit too cheap to pay for any music, so please feel free to put on your own music or just to hum and sing along while I do this. So now we can try making this just a little bit easier and nicer to handle. Again, mostly using fillets and chamfers. We can actually add some chamfers just to the entrance of these pins, which will just help them guide the pins in. They're only slight, but it'll just help guide those pins of the battery into the slots. And again, these will also make sliding the battery in and out a little bit easier. So I think we're just about done with modelling this up. I think the next step will be to export this into Cura and to then send it to the 3D printer and see if all of this has worked. So a mere 4.5 hours later, we have our print. Let's have a look at it. I've done basically no cleanup at all to this, apart from taking away some of the supports that I had to use. Still a few rough edges. Let's see if we can fit our switch in. Fits in. It even sticks out at the top. Our mounting holes. They don't line up. You know what I did? Whenever I measured up for where those mounting holes were, I measured just from the top of the switch down to the center of the holes. But I forgot about this little lever offsetting that. That's a pain. Let's see if our battery fits in. Well, that fits much easier, but I don't know if you can see. You can just see the lip of that green tab, not quite going in far enough to be able to lock in there, so that's not quite aligned right. But the fit is nice and snug, so don't necessarily need that. And if that was the only issue, if that was the only thing, that this tab wasn't engaging into the slot for it, I would just live with it. The fit is close enough, it doesn't really need that. Then there's the issue of the switch, mounting holes not lining up. I could just drill those out, but I want to do it right. If I wasn't filming this, I probably would just live with it. The other thing is, I could just try and print another one, fix the issues without telling you all, but I've run out of this filament. Can't do that either. And as this video is already getting close to 439 hours long, I'm just going to speed up the footage of me fixing these issues and then printing it again. And just like that, in the mere 4.5 hour blink of an eye, we have another prototype on the bench. Here we're looking at the progression of the project, from the first prototype, which we hoped would have so many errors, and you know how I don't like to let you down. Then the second prototype that we had so many hopes for, that would solve all the problems in the first. No, didn't do that either. Then we have the third prototype. This one, will it fulfill all the promises made way back in part 1? Well, let's see. Looking pretty good. Not printed too bad. Let's see if the switch fits. Oh, it's a little stiff as it goes in, but it's in there. I don't know whether it shows up on the camera. Probably not focusing on that. But actually those mounting holes are now in line. I'm really pleased with that. Now let's see if the battery itself fits in. Ooh, that was a satisfying click. It's very snug. It is latched in. You have to depress the tab to get it out. I'm really pleased with that. That is so much better than the previous one. It's really encouraging. It looks like this may well be the final iteration of this. So now we can move into the workshop and cut up a little bit of copper pipe for the soldering iron holder. Something like that. So now we need to cut a length of copper pipe to make our lining for our soldering iron holder. The length that we need is just a little bit longer than the exposed part of this soldering iron itself. So I'm going to say about there is where we're wanting it cut. These pipe slices are really, really handy. And there we go. Now what we want to do is just taper one end of this so that it's kind of closed off so that no solder drips out and onto anything that we don't want it to be on. So in hunting around for some wire wool to clean up this bit of copper, I actually found a little end stop. So I'm just going to go outside now and solder this on, and this will do as a cap to stop any solder or anything dropping out the end. So after soldering up that little cap onto our piece of copper pipe, I then give it all a good polish with wire wool. Brought it up quite nice. Now we need to cut an angle onto this to match the angle here. Now we could push this in. It is very, very tight. Get it all the way up and either mark it and pull it out and then cut it, or try cutting it in place, but I'm afraid that doing that may damage this, and putting it in and then trying to take it out after marking it I think will also result in too much damage. So what I'm going to do, I'm going to actually put it in this way first of all, but only just so that top edge is only just in there, and then I can mark up. Hopefully this pencil mark will show up. Yep, there we have our pencil mark just about showing up there. So I'm going to now take an angle grinder and just cut that off to that angle. I'm not worried about the markings on the model here. The plastic is pretty good and pretty responsive to an eraser. And here we have the rough cut piece. I just need to smooth this down a bit with some files. And so after all this, it fits and it's the right angle. These are just some diamond files that I have. They're really, really good. Looks about right from there. Let's see if we can get it in from the other end. I think I might have to use a little bit of applied violence to be able to get this done. One moment please. And so here we are. You may be able to just see there's a very slight lip on that. But I'm very pleased with that. Except for that. But it will have to do. I wanted that to go in a bit further. But there we go. I'm not going to do it again. I don't have another one of these end caps. So this will have to do. So we'll go back inside and then we can start assembling this and wiring it all up.